I'm Caroline Gorski. I have spent pretty much the last 30 years in the space where emerging technology turns into useful technology. So really understanding how completely new things are coming into the market and what sorts of changes they might bring to the world of work, to our lives as human beings, to the kind of societies that we're building, to the world in general. And I find that fascinating, but I also think it's really important that when we think about new technologies, we understand that we get to have choices about the world that we choose to build using them. And over that 30 years career, I've helped lots of organizations, big ones, small ones, public sector, private sector, people think about, is this technology building the future we want it to build? Are we living in a world we want to live in, or that we want our children to live in, or our children's children to live in? And as the pace of technological change increases and gets more profound, and I think artificial intelligence is probably one of the most profound factors in that, I just want to keep asking that question more and more. Are we actually building the future we want to live in? Because I think there's probably some ways right now that we might not be.
Your framework, which is called Where is the Advantage from AI, suggests that the differentiated advantage in AI doesn't come from technology but from people. Could you elaborate on that, please?
Yeah, so I put this framework together probably in 2017, 2018. And at the time, everybody was sort of running around setting their hair on fire a bit about where did the UK's universities rank globally in terms of technical expertise in building machine learning algorithms and models. And there was an awful lot of navel gazing that went on that said, are we falling behind? Are we losing our prowess? And that stuff's important, but what I sat down and looked at back whenever that was, 7-8 years ago, was yes, of course, technical advantages in algorithmic development can offer differentiation, right? So if you think about the development of convoluted neural networks, or you think about the invention of transformers, those are two really big technological shifts within machine learning and AI that have radically changed the potential for AI models, but both of those underpin to a somewhat or a significant degree the capabilities of generative AI today. So yes, it's true that if you have really, really clever academics, mathematicians, statisticians working on completely novel ways of building out algorithms and managing those algorithms, that can give you some technical advantage. But the truth is that most academic development is built on an open source model. Most academics in the machine learning context share the findings of their information, because machine learning and AI happens at scale, so there's really very little point in keeping it narrowly prescribed, especially if you're in an academic community. What I then kind of looked at was, right, okay, well, yes, we can see some temporary advantage from having the smartest brains building out the algorithms, but they're then going to share those algorithms and they're going to be written on open source code, and in fact, we only have to look at what happened with DeepSeek kind of arriving in the marketplace in January of this year to fundamentally see that happening, right? In reality. They picked up open source based models from the US tech giants, they used it and they amended them, and they added some more of their own capability to them, and they surprised everybody with the sheer ability of the Chinese market to actually respond to the leadership that the US had shown. So okay, technical advantage tends towards being shared. So the next thing you've got to ask yourself is, okay, well, what's the next thing I need that might give me a locked-in advantage from deploying artificial intelligence? Well, AI needs compute, right? It needs really heavy-duty compute. It's actually, frankly, terrifying how much compute it needs. There was a report released by the IEA a couple of weeks ago that says that their expectation is that AI electricity demand is going to double to 945 terawatt hours by 2030, which is more than the entire electricity consumption of Japan. It's mind-boggling. So AI needs compute, and compute is energy intensive, but the reality is that the cost per minute or the cost per petaflop of compute for AI has been dropping radically in terms of price over the last decade. And so whilst 10 years ago I could have been a deep-pocketed technology business and I could have paid for huge amounts of compute to run my model on, and that would have given me an advantage, now the cost of that compute is dropping, and so it's less easy for me to lock that advantage in. I can't guarantee that I'm going to be able to outspend my competition and keep an advantage to myself because the costs are dropping and access to compute power is being democratized. So then the next place where you can see differentiation from machine learning models and artificial intelligence is in the quality of the data that you use to train the model. If you don't have well-engineered, expansive training data, you end up with models that don't do a very good job and aren't very useful for actually generating value. It's one of the reasons why actually China has managed to steal such a march, because China has access to huge amounts of data, because the way that the Chinese culture understands privacy and control of data is different to the way that the Western society understands privacy and control of data. But for most organisations who are not kind of Baidu or Google and don't necessarily have access to an enormous amount of data, the biggest question is the data that's at your command and control organised and structured and engineered in such a way that it can be usefully fed into a training model to be able to inform an algorithm to be able to develop an answer for you. Now this, I think, is the place where there is still, over the next 5 to 10 years, the possibility of organisations deriving some commercial advantage. Because the truth of the matter is that most organisations, certainly any organisation that's more than 50 years old, their data is in an absolutely parlous state. It's mostly unusable, and believe you me, I mean, I spent 7 years working inside one of the world's most advanced engineering firms, and quite a lot of their data was absolutely unusable, and we had to spend an enormous amount of time and energy turning that data into something that we could actually feed into a training model to be able to get an answer out of it. It's the reason why the discussions around copyright and creativity that have been going on in the House of Lords are so important. Baroness Kidron's amendment is about making it really clear and transparent how creative artists' material is being used to train algorithms. But it's fundamentally the same question as the question about how do I gain competitive advantage. And when we think about, where are the places in which we are rich in data, at a societal level in the UK we have an extraordinary potential data source because we have a centralised National Health Service. So the NHS, albeit an NHS data is also not in very usable state in many instances, but the fact that we have a centralised National Health Service gives us an extraordinary advantage in the rest of the world with being able to think about how you train models for health outcomes. But we desperately need to understand that competitive advantage at a national level is something that we shouldn't simply be giving away for access to other things, trade agreements, access to big tech capability. It's a really important thing. But that differentiation, that data-led differentiation, is probably only valid for another 5 to 10 years for most large organisations, because by that point, their competitors may have moved faster to sort their data out. That advantage will be lost, that space will be game over. So far I've kind of walked us through a framework that says, okay, well, AI is algorithms, and then you need data, you need the capacity of actually doing the compute to generate those algorithms usefully in the world, then you need data to feed those algorithms. And at the end of that process, you might have a machine learning application or an AI application that's presenting some recommendations or making some predictions or showing how a different choice in a decision might happen. Great, but even with the rise of agentic AI and the idea that you're going to have automatic AI-driven bots going out and actually executing decisions, the reality is in most businesses that the bit that goes from a recommendation or a prediction or an idea to actually something happening, which results in a new product or a new service or lower costs or more revenues or more accurate work, that interface is a human being. It's still the case that in most instances, most processes inside most organisations are driven by or instigated by or managed by human beings. If you aren't able, you still need all the things we talked about before, right? You still need brilliant academics, you still need novel technologies and models, you still need compute power, you still need well-engineered data. If you don't have all of those things, you haven't got an AI capability. You just can't differentiate on those things. But if you train your people, if you work with your people to help them understand how the new technologies that are being presented to them can radically transform the work that you do inside your organisation, then you can definitely still get advantage over whoever else it is who has got all of the rest of the hygiene factors that we talked about in the beginning of this conversation. And for most organisations, the idea of sitting down and working with their workforce to really help them learn about what it means to be in an AI augmented working space is still a long way away. Even the most advanced organisations, management consulting firms, law firms, technology firms even, struggle with the kind of fear and resistance that arise because people look at automated decision making and are worried that it's going to take their jobs away, that it's going to make their skills redundant, that they don't have a place in the future that's being built. And so that's why I think the biggest place for differentiation, for competitive differentiation, for organisations who are interested in deploying AI, is actually in the imaginations and capabilities of their people, rather than in all of the other things that they're going to need anyway, but are not going to give them an advantage in the end.
So in your presentation, Learning to Speak Machine, you explore how we can work more intelligently with LLM prompts. How do you see the relationship between human language skill and effective AI implementation?
So this is, again, a really interesting research space. And I actually came to it by thinking about what at the time were called pervasive connected machines. So probably when we all started having, a smart home assistant, an Alexa or a Siri or whatever it was in our house, and we were buying Fitbits and connected devices to wear on our wrists, and we started having a sort of very intimate, permanently on connection with a whole range of new devices. And one thing that was really interesting about that was that explosion partly came from a couple of big technological shifts. One was being able to build much more responsive natural language processing models, so that the fact that you could speak to a machine in natural language and it would understand, you could issue it with a command, suddenly made this technology much more accessible to people who might never have wanted to learn how to use a command prompt or whatever, Unix. And I was excited by that opportunity because it democratized this technology, it made it more accessible to people. But I was also a bit concerned about it at the same time, because what happens when you create a completely invisible interface between humans and technology is that you abstract the human being away from what the technology is actually doing. And it's a bit for me like car mechanics, right? I'm old enough that when I was at school, I was taught how to lift up the bonnet of a car, find the fan belt, change the fan belt, find the spark plugs, change the spark plugs, and, check the oil levels. And now, if I lifted up the bonnet of my car, I couldn't find the fan belt or the spark plugs because they're actually locked away under a bolted down cover to stop me fiddling with them. And actually, even my mechanic at my garage, the first thing he does when he gets into my car to give it a service or check for something that's wrong, he doesn't open the bonnet and look at the engine. He plugs a device into the dashboard and the onboard computer tells him what's wrong with the car, or tells her what's wrong with the car. So not only have I been completely abstracted away from being a kind of partially informed car operator, but my service engineer has been abstracted away from needing to really exert their professional knowledge as the first diagnostic point. So why is that important? Well, because as we start moving into the world of large language models and using large language models much more day-to-day way in our lives, they are incredibly sophisticated in their ability to engage with us in a quasi-human way. You can ask them a question in completely human natural language and they will give you an answer. And it's one of the reasons why they've taken off so quickly. But the difficulty with that is that sometimes, often in fact, the answers that you get back are extremely superficial but appear very slick and very comprehensive. And so learning to prompt more effectively is a new skill. It's a skill that we don't teach yet in schools, and we really should. I think teachers are probably, and understandably, quite scared about what happens if we teach prompting, because then we will get answers coming back from LLMs that are even, less easy to pick out from a plagiarism test than currently is the case. But we need to understand what it means to do a good job of prompting an LLM. How do you help the model by setting it the kind of parameters that you need it to follow to give you answers that are accurate? There was two really interesting studies that have happened in the last few weeks. One from MIT, where they looked at whether or not an LLM is better or worse at persuading human beings than a paid human being. So they had one set of human beings who they paid money to persuade another set of human beings of something that was factually incorrect, right? And then they had an LLM who they are told to persuade the human beings of something that was factually incorrect. And the LLM beat the paid humans. So, large language models are now better at persuading human beings that black is white. It wasn't actually black is white, but you know what I mean, than other human beings are. Just stop for a moment and have a wee think about that, because that's genuinely terrifying. And then secondly, there was another study published in the Royal College from a Dutch university, and they looked at whether or not the LLM models were doing a good job of summarising scientific papers. And indeed, whether or not LLM models did a better job of summarising scientific papers accurately than human summarisers. And what they found was the older LLM models are making a number of errors, particularly oversimplifying findings, or making recommendations based on findings that are actually misleading, removing doubt, if you like. Scientific papers often contain quite a lot of doubt and parameters of doubt, because they take very seriously their responsibility in only making recommendations that are proven by the evidence. And the LLMs were removing that doubt and making much more certain proposals from these scientific documents. So that's one thing. But they then found not only is that true, but the newer models are worse than the older models. Now, one of the reasons that the newer models are worse is because the designers of the newer models have started to factor in more helpfulness in the way that the LLM responds with the human. So two things happen. One, the LLM stops refusing to do things that it finds too hard and just does it even though it doesn't really know the answer. And two, programming an LLM to be more helpful, or some people describe it as more sycophantic, encourages the LLM to present you with the answer it thinks you want, not the answer you actually want. We are in this space now where if we don't understand as prompters, as askers of questions, how the questions we ask can be answered in ways we were not anticipating, we are likely to generate answers for ourselves that are not only misleading, they're actually getting worse over time and not better, which is really counterintuitive, because you would imagine they would improve. So I think it's really important to think about what it means to be a good prompter, to ask good questions. And one of the best ways to start is just by asking the LLM, whichever one it is you're choosing, how do I write a good prompt for you? What do you need me to do? Like, literally go and ask it, because it will come back with a set of answers that says, if you tell me to do these things, I'll behave in this way. If you tell me to do these things, I'll behave in that way. You can set me these parameters. You can set me those parameters. But also, not only think about how you become a better prompter, but also think about what it is the LLM is doing with the questions you ask it. Because it isn't just answering your questions. It's learning from the questions you ask. So it's learning how frequently that question is asked, what importance is given to that question, what tweaks and amendments are made to that question. Every time you ask it a question, it learns from you what sorts of questions it's likely to be asked again in the future. So the better the questions that you ask it and the more demanding the questions that you ask it, the more likely it is to learn to give good answers rather than rubbish answers. But I would also say it is worth also thinking about the fact that when you ask an LLM a question, you are effectively teaching it for free. In fact, sometimes you're teaching it and paying for the privilege of teaching it. So that's another thing that is maybe worth just keeping in the back of your mind.
Your work identifies several wicked problems in the digital world, including the lack of practicable ethical frameworks for AI deployment. How can businesses navigate these ethical challenges while still driving innovation?
I don't think this answer will come as a surprise given the kind of framework that we were discussing slightly earlier in the conversation. But for me, maintaining the kind of ethical realities or building out ethical realities for your use of artificial intelligence has to start with people. And it has to start by talking to people up front. When we built in Rolls-Royce, I was responsible for leading a team that developed Rolls-Royce's artificial intelligence ethics framework, which is called Alethea. Now, we published that under Creative Commons license, so it's still available for anyone who wants to have a very hands-on, very practical framework for thinking about developing artificial intelligence applications and ideas. It's still available. You can go to the Rolls-Royce website and download it, and please do. But one of the very first conversations the team had when they were building out that framework was actually with the unions. It was with the Rolls-Royce union stewards to say, we are thinking about the rules we want to set for ourselves as an organisation for deploying artificial intelligence. We understand that this will have an impact on some jobs within the organisation. We would like to sit down and talk to you about what that means, right? And how we need to think about that and how we should be working with the union members to help them understand what new skills do they need to learn, how can they integrate these capabilities into their jobs, how do we make sure that we don't, just undercut them in terms of the ability. And so that for me, it is still even if you don't work in a unionised industry, even if you don't have that model of engaging with your employees, I would still argue that the first most important people to talk to about how to deploy artificial intelligence are people. And that might be your staff, or it might be your customers, or it might be the people who actually own and have given you the permission to use the data that you're using to train the AI. So if you're thinking about, if you're a business to consumer business and actually what you're trying to train an AI on is customer data, then it isn't your data. It's actually your customer's data. Now, they may have signed a piece of paper or ticked a box on a checklist that says, yes, you can use my data. But even if they've done that, it's still really their data. I think that, for me, is the single most important conversation you can have when you're thinking about how to deploy artificial intelligence ethically. There are some other things, though. I would encourage organisations thinking about wholesale or large-scale transformation from AI to go through at least one cycle of much longer-term planning than they would normally do. And by that I mean, don't sit and think about a 5-year plan. At the very least, sit and think about a 50-year plan. And if you can do it, think about a 500-year plan. Now, the last one's really hard, and I've been working on some approaches to that, more of which will come over the next year or so. But so at the very minimum, you need to be thinking about what is the future of this organisation that we are building for our current customers, employees, and shareholders, and then the next generation and the next generation. Because artificial intelligence has the capacity to be that transformational. And so if you don't put it in the context of a 50-year plan, you run the risk of adopting something without any real thought about where that transformation might take you over more than a 5-year traditional strategic planning cycle. And part of that longer term planning is about thinking about the byproducts or the unintended outcomes of artificial intelligence, whether that thinking about energy consumption, like what does it mean to be a truly AI-led business in terms of how much energy and water you're going to need, or your suppliers potentially are going to need to service your needs for actually deploying those applications in your processes. And then, so there are a number of really long-term questions that I think would be helpful to ask yourself so that you can frame some ethical boundaries today in how you want to take your AI programs forward. And then I think the last thing is, if you don't explicitly already have the rights to make the changes you want to make, whether that's because you don't have the rights to the data, or you don't have the social contract with your staff, or you haven't really given enough thought to those byproducts, those environmental impacts that you might have, then if you don't have those rights explicitly granted, then the best thing to do is set up some small experimentations protected by guardrails where you can show what it is you want to do and then seek the permissions that you need to be able to actually take that implementation forward. And that style of development fits very well with the way that machine learning and artificial intelligence works. It's an experimental, iterative process. And so by doing that, you will actually help your initiatives to be more successful anyway, but it also gives you the ability to be very transparent about, we want to do this, here's our first attempt at it. We understand that we don't have the permissions to do all of these things, we are asking for those permissions.
You've developed frameworks to help companies identify where differentiated advantage actually comes from in AI implementation. Could you walk us through how a business might apply this approach to transform strategically? So
we talked before about this idea that whilst you're going to need algorithmic novelty and really good algorithms, good maths, you're going to need the provision of data processing capability, cloud-based processing capability at scale. You're going to need some novel ideas also to explore. So we talked about those things, but we talked about the fact that they're kind of hygiene factors, right? That everyone needs them. You just need them. You just have to have them. The first thing I think that's really important, and again we mentioned this a little bit beforehand, in terms of actually getting to strategic transformation, is to understand what data you have and what state it's in. And indeed what permissions you have for that data, going back to the previous conversation we had. So unless you have a good handle, like a data audit, a good handle on your sources of data, the quality of your data, how well engineered it is, how accessible it is, and whether or not you have actually got the permissions, actual or moral, and I would describe those two things as slightly different, permissions to use it, unless you know that, then all you're going to be able to do in the immediate term is some pilots, is some proof of concept testing on small collections of data that you might be able to get together. But you are likely to find, when you want to move from your proof of concept into scaling, that you then have a problem, right? Because your proof of concept won't be robust enough to scale, and if you haven't done a data audit and you don't understand how big the challenge of getting your data into a useful form is, that may become overwhelming. The world of machine learning and AI in terms of business transformation is littered with examples of really promising proof of concepts that never went anywhere because the data was just so badly organized or so badly engineered that it wasn't possible to actually do anything at scale with what looked like a promising solution. So do I have a good enough evidence base is your first question. So your second question comes back to that point that the real differentiation in you being able to build this thing and have it deliver value is in your human resources, right? Your human capital, the skills that your people have and the confidence they have in actually using those skills. So the next thing you need is a skills audit. The next thing you need is to actually ask the question, how ready are my people if I gave them a machine learning or AI driven automation and inserted it into one of their work processes, how ready are they to use that? How comfortable would they feel with that? Would they resist it? Would they outright reject it? And those things, again, happen time and time again. So along with all of the litany of really promising data science projects that never went past proof of concept, I can give you an equally long list of really promising data science projects that got launched into test teams in the business and so wholesale rejected that they never went anywhere. And they were rejected because people found them threatening, or they interfered in a process flow in such a way that people could not get used to them working, and they didn't see enough advantage from participating in them, and so they just rejected them. So the second thing is, am I ready to start, actually? And if you're not ready to start, then it doesn't really matter how good enough your evidence base is, because you'll end up with a beautiful machine learning application that nobody uses, and some people actively reject. So am I ready to start is the second question you need to ask yourself. And then the third thing you need, and again, this is really important. I was reading a paper from a colleague in San Francisco about industrial automation last night, and she made the really, really powerful point that in industrial processes were designed in the 19th century to give a kind of Jeremy Benthamite optomicron kind of single point of control, right? So industrial processes are designed to make a manager be able to control the entire process of a factory from one single seat in his office. So they're very linear and they're very siloed. And if what you're trying to do is use artificial intelligence to connect knowledge and information up across a range of processes to transform an entire system, then you've got the wrong sort of process to be able to be transformed, right? You're kind of fighting against the structure that's already in place. So the last question you need to do is a process audit, which is actually, how are my processes designed today? And can I change them? Because if they are those very narrow, very siloed command and control processes, you're actually going to have to do some process redesign work up front before you ever get to deploying an automation from an AI or an ML, because otherwise you literally won't be able to make the changes across the system that would generate the transformation and the value that you're looking for. And then after you've asked those 3 questions, have I got a good enough evidence base? Am I ready to start from a people skills perspective? And do I have processes I can actually change? Then the next thing you need is you need to put in place, before you even start, a governance layer which says, are we building the future we want? Because you can have all of the things I just talked about. You can have good evidence bases, you can have people who are ready to work using skills that are appropriate, you can have processes that are ready to change, and you can still end up building a future that nobody in your organisation really wants to be in. Except maybe your shareholders, but I'd argue even them, probably not. So, are we building the future we want? Is 3 questions. How is this helping our commercial success? What is the impact this has on people? And when I say people, I mean your staff. And then, what is the impact this is going to have on society? And when I say society, I mean both your customers, but also the environment that you operate within. Because if you don't answer those 3 questions, and this goes back to the previous point about, do at least one cycle of a 50-year plan. If you don't answer those questions, you run the risk of putting into train a set of transformations that end up with you turning yourselves into something you never really planned and, frankly, maybe don't want to be.
How does inclusive innovation, bringing diverse perspectives into AI development and implementation, create business advantages that might otherwise be missed?
I'm not your average artificial intelligence leader, right? A, I'm a woman, still fairly not average. B, I'm an arts graduate, not remotely average. One of the things that I've found fascinating around my career latterly, so the last 10 years of my career when I've been building AI teams, building data science teams, is it became painfully obvious to me that this was not a very broad and diverse population. As you would probably expect, there's a very, very high level of academic success, so that means that many individuals who don't have a traditional academic background are excluded from participating in this world, which I think is a bad thing. It's quite male dominated. It's even more male dominated when you're doing data science in an engineering business, because the engineering business itself is male dominated, so the kind of pool you're picking from is already very skewed. It tends to be mostly people of a Caucasian background, so white background, Caucasian ethnicity, or in some instances Southeast Asian. Very, very low levels of African heritage individuals in most data science communities, which is a terrible outcome when you think about the populations who are going to be having their futures built by some of these technologies. There's a higher than average representation of neurodiversity, but there's a much lower than average representation of LGBTQIA+. So with all of that in mind, when we started building out the data science community for Rolls-Royce, partly because we just thought it was the right thing to do, we worked really hard to reach out to and appeal to and attract a much more diverse group of individuals. So we had psychologists, we had actors, we had people who'd not gone to university at all but showed a kind of innate interest in pattern matching. We ended up with a population that was about 52% female. It was about 48% black and minority Asian ethnicity. It was about 40% neurodiverse, and 25% of the leadership team were LGBTQIA. So it was a very, very diverse population compared to many data science communities. And why does that matter beyond, just because it's the right thing to do? Well, it matters because you end up with better quality data science. Because you have a wider range of experiences And that wider range of experiences gives you more exploratory fields to apply your models to. More use cases, more ideas about what might be useful or impactful. It also gives you much better awareness of data bias and data scarcity from particular populations. And it gives you a much better understanding of confirmation bias, which is probably the single biggest bias factor that people fail to control for when they're doing early stage data science work. It gives you a much more sensitivity to user differences, so you end up building much better and more adaptable outputs because you understand much wider range about how users are going to use the tools that you're building, and that gives you faster growth because it gives you higher levels of acceptance with a bigger community of users. You get much more interesting problem scoping, so people come up with really novel ideas that you wouldn't necessarily have, and you have network effects over time. So one of the things that's really interesting about a diverse community of data scientists is that tenure of a data scientist is quite short, still sort of 2 or 3 years, but when you have a really diverse community, they go off to do their next job and they're also in a more diverse community, right? So you end up with this incredible network effect where the fact that you started with a more diverse group over time just gives you far more reach into far more diverse experiences, and then you can call on them later. So like I'm doing now with Terrestrial, I reach out across my community and go, hey, I've got this idea I think I would like to explore. Has anybody got any alternatives or different things? And that's really powerful. So you can have multi-generational network effects of diversity, which continuously serve to improve the quality of your data science. And then the last reason why inclusive innovation gives business advantages is because it's a hell of a lot more fun.
So when looking at power consumption, cryptography vulnerabilities and employment shifts caused by automation, what priorities should business leaders focus on first to ensure responsible AI adoption?
So when I think about the wicked problems that come from some of the changes we are making to the world that we live in, and I come at this, as I said previously, I come at this from the view of being a historian. So I come at this, if I'm honest, by looking back to big seismic social shifts that we've seen in the past and trying to understand what were the questions that we didn't ask then and how can we ask better questions about that now. And for me, that question about are we planning over a long enough time horizon has to be the single most important one. Because we can happily, and we did, let's be really honest, we have been talking about the pernicious impacts of climate change for at least the last 40 years. And I'm sure much longer in academic circles, but in terms of, in the public consciousness, I remember learning about it at school, and I'm that old, so I know it's been at least the last 40 years. And yet, it has only been in the last 5 that we have even really started to grapple with the impacts of what our reluctance to make any changes during that period have done. And it's because, forests are burning and places are flooding and whole categories of people are being displaced from one part of the world to another part of the world. And the Global South has stood up and said, we are bearing the brunt of all of this, and you have done nothing for the last 150 years, 250 years, but certainly nothing in the last 40 years. And part of the reason that failure has happened is because we are very, very bad at long-term planning. It is easy for us to look backwards. It is very hard for us to look forwards beyond 1 or 2 generations. We find it almost impossible to imagine a future for our children's children's children because we don't think that way. We think about 80 years and 10 that we're going to be on this planet, and maybe we think about our children's 80 years and 10 as well if we're, if we've got that sort of longevity in mind. But beyond that, we just don't think. So for me, getting ourselves into a mindset where we can think longer term, and indeed where we hold each other accountable for longer term planning, is really important, because that's how we ask the question, are we building the future that we want? And that's how we ask questions about where is the trade-off, right? Where is the trade-off between today's wealth, comfort, ease, and the future's apocalyptic desert, which is, to some, in a climate change sense, kind of the reality of that question, right, over a millennia of thinking. And I think that understanding that long-term plan helps us make better decisions about the short term. It helps us make better choices about the tiny little steps that we're taking today, that we're making towards that future. But at the same time, I don't want anyone listening to this to think that we aren't facing into some pretty hairy challenges today. I spoke before about that work from MIT around the breakthrough of LLMs, of bots, essentially, in being able to be more persuasive to humans than humans are. And I want just momentarily for us to think about that in the context of the breakability of public key encryption. So public key encryption, the ability to safely encode a stream of data using a public key at one end and a private key at the other end, is essentially one of the formative technologies that unlocked the power of the internet, because it meant you could transact safely, right? It meant I could send money to you and I could lock it at my end and you could unlock it at your end, and we could do that at scale. And it's genuinely a key formative technology. And it's based on prime numbers, which means it's very hard to break unless you have an actual quantum computer, like a real powerful quantum processor. And then it's really not difficult to break at all. And so now we haven't got quite there yet, and we've been talking about, commercially available quantum processing for what feels like a decade. It's probably more like 20 years, but we're much closer than we were. If we think about the breakability of public key encryption and the rise of artificial intelligent agents, so these are bots that are commanded and interact with other bots. So suddenly I as a human set one bot a challenge. I don't know, let's imagine the challenge I set this bot is go and find me 2 million in clear credit card numbers that I can use, for example. No, I wouldn't do that. I'd just like to point that out. It's illegal. But anyway, but I could, right? So now a bot can go off and negotiate with another bot and 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 another bot. And maybe one of those bots, instead of trying to break into a big retailer's online servers, instead of doing that, they go, do you know what? I'm really good at persuading human beings to do things. So I'm just going to go and find a human to talk to, and I'm going to persuade that human to give me the password to the files that hold the financial accounts for, this said big online retailer. And I know I can do that because I've been trained how to persuade humans. I understand what buttons to press. I understand how to present an argument that feels credible. I can pretend I'm their boss. I can pretend that there's an emergency and the data center's burned down, and so we need to get into the backup servers in order to be able to make this information. There are a number of ways that you could do it. All of them rely on what's called social engineering, which is the sensitivity and the insecurity of human beings in the loop, especially when those human beings are being manipulated by machines. And being manipulated by machines who have been taught how to manipulate them. So now, I'm not sure that 5 years ago, when we were talking about quantum public key encryption and the very early beginnings of AI agents, and LLMs for that matter, that we imagined that scenario. Maybe we did. I'm sure some people probably did. But it's very real. It's not very far away. I'd be absolutely staggered if it isn't already happening.
As Terrestrial prepares for launch, what key message about AI transformation do you want business leaders to understand that they might be overlooking?
So for me, I think if we want to build this future that we actually want to live in, then I think we need to build that future knowing what it is that we value and knowing what it is that we would fight to keep in that future. So fundamentally, Terrestrial is about finding exceptional people who might find themselves in a position of difference, and helping them to know themselves better so that they can work out what it is that they want to fight for, and then to equip them with the creativity and the resilience and the skills to do that fighting, to do remarkable things, in order that that future we're building is a future we really want to live in. So if you are an employer and you aren't thinking about the power of the exceptional people in your organisation, then you are going to find that the future evolves without you. So I would encourage you to think harder about them and how they can help you build the future you want and